Now we want to talk a little bit about elementary matrices. These things are, elementary matrices are very powerful, especially in the way we use them. So first of all, here's our 3 by 3 identity matrix. Now we can interchange the first and second row. We can reverse those two rows of the identity matrix and we get this apparent clearly. The 1, 0, 0 row becomes the second row. The 0, 1, 0 row, which is the second row, becomes the first row. Now if we multiply that matrix by the matrix 1, 0, 3, 0, 2, 4, 1, 1, 0, the matrix we've been using a lot of, what happens? Well, 0, 1, 0 times 1, 0, 1, 0 multiplies a 1, 0 multiplies this 1. The only thing that's not 0 is this 1, which multiplies this 0 in the middle, but that still gives us 0. So first row times first column is 0. First row times second column. Now, again, the first number is going to multiply the first number, the third number is going to multiply the third number, and both the first and the third number in this row are 0, so we're not going to get anything from here or here. But the 1 here will multiply this number in the middle, which is 2, giving us 2. And then 0, 1, 0, acting on the column 3, 4, 0, picks out the 4, doesn't it? Okay, the 1 multiplies the 4, everything else is multiplied by one of the zeros, so we're going to get 4. And then 1, 0, 0, you can verify, multiplied by this column, well, the 1 multiplies the first number, and that's all we get because of the zeros here. And, of course, 1 times 0 is 0, and the rest are zeros. And 1 times 3 is 3, and these zeros, of course, are going to give us 0 no matter what the second and third numbers are. So we get 3. Then 0, 0, 1 multiplied by this matrix, we get the third row, 1, 1, 0. Now, what has happened? How does this matrix compare to this matrix? Well, you should be able to look at it and see exactly how this matrix compares to this. There's a simple row operation, legal row operation, that'll take us from this matrix to this. Do you see it? You should stop until you do. But it should be very clear now, because I'm going to tell you, that this row 0, 2, 4 is now in the first row, which, the second row is now the first. And the first row here is now the second. So we've interchanged these two rows. Now it's kind of neat that we did that by multiplying by the matrix that we get from the identity matrix by switching the first two rows. So if we multiply by a matrix, by a matrix that we obtained from the identity matrix by switching two rows, whichever two rows, and if we multiply our matrix by that matrix, the result is going to switch those two rows. Okay? Now you don't know where this is going yet, but it turns out that this is one type of an elementary matrix. There are 3 types. We'll see the second type here, and there's a third that you can learn about. The really neat thing about about elementary matrices is that they're really easy to invert. So if we want to find the inverse of an elementary matrix like this one, it's very easy to do. We'll see that, and we'll see how that's used in a subsequent video. Okay, well, now, what did we do to the identity matrix to get this matrix? Okay, you should stop until you see what we did. What operation? There's a simple row operation that we did. A single row operation on the identity matrix gives us this matrix. Okay? Well, clearly the row operation is multiply the first row by 2, right? Other two rows stay the same. Well, if now I multiply this matrix by our 1, 0, 3, 0, 2, 4, 1, 1, 0 matrix, you can verify that I get this result. Okay, now, how does this matrix follow from this? By a simple row operation. Do you see it? Stop until you do. Okay, well, the answer simply is that I've doubled the first row. What did I do to get the elementary matrix from the identity matrix? I doubled the first row. So, this is always going to be the case. An elementary matrix is a matrix that you get from the identity by applying one single valid row operation, either interchanging two rows, multiplying a row by a constant number, or adding a multiple of a row to another row. I haven't done one of those. If I add 4 times the first row to the second here, what am I going to get? Well, I'm going to get a 4 here. It's going to be the same as this matrix, except I'll have a 4, 1 here. If I multiply that matrix by this one, I'm going to get what I would get if I added 4 times this first row to the second. Okay, so you should write that down and think about it, but that's how it works. Okay, so that's what the elementary matrices are. Now we'll talk in a little bit about inverting the elementary matrices, but we're going to go on and see something here about these elementary matrices. It's important for our later use of those matrices.